not equals to 0, and it is of the form this f1 xy y dx, f2 xy x dx. Then this is integrating factor, and then we have mx plus ny not equals to 0, then 1 upon mx plus ny is an integrating factor. Then this also we have discussed, okay, these two forms. Okay, here if it is a function of x alone, then e power integration fx dx is the integrating factor, and if it's the y is the it's a function of y alone, then this one. Okay, so let's do this. Sometimes by looking at this equation also, you can know whether you can get any integrating factor or not. Okay, so let's say solve the differential equation minus x dy plus e power 1 by x dx equals to 0 by finding an integrating factor. So what you can say by looking at this equation, what you can think of as integrating factor? So you can see the first term, this is y dx minus x dy. Okay. So here this will be minus term is there. If it is plus, you can see this part will be the exact differential of d of xy. You can write it. Okay. But here since minus, but you can do one thing, you can divide it by x square. This minus x dy is there. So then you will be having y by x. It will be the exact differential of y by x. And if you divide it by x square, and you see e power 1 by x square, if you write, then we can also see this as the derivative of 1 by e power 1 by x. So here 1 by x square you can consider by looking at this one. Okay. So we can try 1 by x square as integrating factor. Okay, we have very few, like 4 theorems given to you. Only those are there. Otherwise, you can most of the times you can look at the equation and you can find. So if you multiply the first term, you see y dx minus x dy divided by x square plus e power 1 by x square dx equals to 0. Okay, this is d of y by x minus d e power 1 by x. So now you can get it. This is y by x, and here plus e power 1 by x equals to constant. Or further, you can write it e power x. Okay, so this is how you can answer. Okay, by inspection, you can look at this. Okay, so now next question. Solve the differential equation. what you can think? This one, you look at this and try to solve this one to check whether it's exact or not. Okay. So whether it's exact or not, and you try the methods, for the integrating factors. So you remember the integrating factors? So first we did for 1 by mx plus ny. Okay. Provided it's 1 by mx plus ny when it happens. What was the condition? Not equals to 0 and homogeneous. Then this will be integrating factor. And this mx minus ny. Then this is, so this 4 and by inspection. Okay, so you find out which one. Find integrating factor. So now this is mdx plus ndy form. Okay, the standard form. Okay, now you find out whether it's exact or not. See, the equation is not exact. You can see here. So here del m by del y, so it will be 6y plus 2x. Okay, minus is there. And del n by del x will be 2x. And here we have 2x, 4x. So here, sorry, this will be del n by del x. So here 2y plus 2x. So they are not equal, not exact. But these two are homogeneous. You can see they are of degree 2. So you can try 1 by mx plus ny provided they are mx plus ny not equals to 0. Are homogeneous of degree 2. Okay. So now you see 1 by mx plus ny. You can see only one condition you have to check, mx plus ny not equals to 0. So you multiply here 3y square x and you multiply here plus 2x square y. So here it will be ny 2y square x, and here we have 3y square x. So, and this will be x square y. Okay. So here there it's not equals to 0. So you can proceed with this one, 1 by mx plus ny. Okay. So try this way. Consider this one as your integrating factor. Find out 1 by mx plus ny and find the solution. This is the integrating factor. Are you reading? Anyone done? I gave you the integrating factor. Anyone done? Suman, you are done. Or you are trying.
Integrating factor is 1 by minus xy into x plus y.
Could you speak a little loud?
1 by minus xy into x plus y.
Yes, ma'am.
Answer you are saying 1 by x
Integrating
plus
factor.
y. Okay,
Integrating factor
what is the integrating factor?
1 by
So
minus
after
xy
solving
into x
1 by
minus
xy.
into x plus y.
Okay, this is the integrating factor.
Minus.
So
Minus, man, minus.
minus sign is there.
Yes, ma'am.
Minus 1.
Yes, man.
Why minus sign? You can take this one minus this one plus also, you can see. Okay, let's see. So now we will multiply the integrating factor with this equation. So if you multiply it, what we are getting? 2xy plus x square dy. So x, if you take common, we have 2y plus x and we divide it by xy x plus y. So whether you multiply minus 1 or not doesn't matter. Okay, minus sign, if you take it here common, that will be taken care of. Now here we can cancel out x, y. So now what we can do? Fraction, partial fraction. Now you can see this equation is exact. Okay, if exact, then we will proceed with the solution of the exact differential equation. Okay. So this equation is exact. So the equation is exact. You can check. How do you multiply minus? This becomes this. And m 3y plus 2x. You solve and let me know. So use partial fraction. So if you remember the solution, u of xy, what we have done, m dx, and we keep the here y constant. We treat y as constant. And here we consider only the terms which are independent of x or which do not contain x. Only those terms. Do it, and what is your answer?
Ma'am,
Yes.
m should be negative.
N will be negative. Yes, we have made it minus. One of the should be n or m must be negative.
Yes, ma'am.
So you're able to make it into fractions, partial fraction, then integration will be easier. So here it will be 1 by y plus 1 by x plus y. Will it work? X plus y plus y will be 2y plus 6. Not it is a simpler one. And m, x and x plus y will be two terms. So we will have 3y plus 3x minus x will be 3y plus 2x. Okay, so this is your uh, fraction form. Okay. So if you do this one, m by treating y as constant, so here we have 3 by x. On x minus okay. Now this n term minus term is there. So we only consider the terms which do not contain x. So only the first term. So minus 1 by y. So I think it is minus on y. So we are putting modulus so that this logarithm will be well defined. So this will be a constant. you want, you can also put this logarithm here. Okay. So further, if you do, this will be x cube. So this is how I can. So one more question. Solve the differential equation. Okay. So you solve this one. Okay. Check if you can go for any integrating factor. So what will be the integrating factor here? So we have m. So this is m. This is n. Okay. So check whether it's exact or not. So del m by del y. So we have 6, 3, 9 x square y square e power y plus 3 x square y cube e power y. Similarly, del n by del x. 3 x square y cube e power y minus y. See, you have this, they are not equal, and you see if you can use anything del m by del y minus del n by del x divided by y. So that form you can use if which form you can use. So if you subtract this one minus this, whether you are getting anything, see this term will get cancelled out. Y we will have 1y left. So if you divide it by this, whether you are getting, let's see, del n by del x, del n by del y minus. See, when you are finding the exactness, that time you can look at it and you can check. So what we will be left with x square, y square, e power y, and this term will get cancelled. Okay, so this one and this one. So plus 3y square plus y. This is what left. Now m, you look at m, and if you divide it by m,
Ma'am, 3y, right?
3, I missed something.
3y.
Oh, 3y, yes, 3y. 3y. Now if you divide it by m, so you see you divide it by m or n, both are there. Okay, possible. I think if you will divide by m, it's near to that. Let's see. See this second, whether we divide it by m and looking at this one, okay, from the exactness, while you are finding, you can check this one. Okay. So this will be 3 is common, so we can take out 3 x square y square e power y plus y square plus y, and we divide it by m. So m 3x square y cube ey plus y square y cube plus y square. Okay. So you can take common y here. You can see if you take common y, here we will have square. Square. And here also is y square. Okay, because it was y cube, it was y square. So now you see you can do the cancellation and you are left with 3y. So it will be only the function of y. It's a minus gy form. Okay. So this is minus gy form. Okay. So our integrating factor will be e power gy dy. Okay. So you see if your minus cy is 3 by y, then g of y will be minus 3y minus 3 by y dy. Okay. So it will be e minus 3y, and you see logarithm, so it will be y power 1 by 3, y power minus 3, or 1 by y cube. So this is your integrating factor. Okay. Now if you multiply both sides of this equation, then what you will have? Multiplying the integrating factor. So as the normal process, then we will start. So we will have 3x squared or y plus 1 plus 1 by y dx plus x cube e power y minus x by y square dy. Now you can check for the exactness. Okay, it will be exact. Okay. So you can check whether it's exact or not. Okay. Then you can try that form of exactness. Okay. So this equation is exact. You check yourself. Okay. Then you can try the solution of this one will be ax square ey plus 1 plus 1 by y dx. So we did here y constant. In the next term we have x cube e power y minus x by y square dy. So here we treat, we only consider terms not containing x or independent of x. But here every term contains x. So 3x square, so this will be x cube e power y, then 1, so y constant, so it will be x, and this will be x by y constant, so x by y. Okay. Constant. So this is your solution. So now you have some idea. Now we will go to the linear differential equation, the next one. Okay, you have to practice. Okay. So you can practice from this Zen angle. There are many problems. Okay. So now we will move on to the linear first order differential equations. Okay. See these integrating factors. You see, you go for the exercise 4.4 for Zen angle. Okay. You try this one. So many problems are there. Okay. Check. If you have the book at the end, I think answers were also there. Answer keys, so you can match there. But you try, you have all the options. Okay. Then we have linear first order equations. Okay. So linear first order equations. So a differential equation of the form of the form dy by dx plus this is the linear differential equation of first order. Okay. So the general solution of this will be of the form. So here, you see, the integrating factor will be always of the form e power integration p dx. Okay, this p is the function. Okay, the integrating factor of the non-homogeneous first order of the non-homogeneous first order this one y dash pxy tends to qx px dx. So anytime you have the equation of this form, without thinking, you simply use the integrating factor e power px dx. Okay. And you can then you multiply it with, and your solution also you can write. Okay, if you want, you can directly write the solution. Okay, that means you can check. Okay, you multiply this like we did. You multiply this integrating factor, and you will see it will be exact differential equation, and you can find the solution. But here I am giving you the solution also directly. Okay, you know how to find the solution of the exact one. So if you want, you multiply it and find out your solution. But here I am giving you the solution directly. First order solution of one, that is first order linear differential equation, y equals to e power minus px dx. So it's multiplied with q of x, then e power this is the integrating factor. Okay, plus the constancy. Okay, so here this constant is also inside the bracket. Okay, so this is the solution. That is the integrating factor, and this is the solution. If you want, you go and find the integrating factor, or you directly put it in the solution. Okay, so here let's see one simple example here. So x dy by dx minus x plus 1 y equals to x squared minus x cubed. So you see whether this equation is of the form or this one, the linear differential equation of first order. But here you see the coefficient of dy by dx or y dash is 1. So we will make it that way. Okay. Then we have dy by dx minus x plus 1 by x, y equals to x squared minus x cubed. Sorry, here x term will, we divide x. So it will be x minus x squared. This we are dividing x for the equation. Okay. Now you can see this is of this form. Okay. So this one will be p of x and this will be q of x. Okay. So p of x. Now you can, if you want, you can directly put, or you can find the integrating factor. Okay. So the integrating factor here will be p dx. So here integrating factor minus x plus 1 by x, so dx. So if you further simplify this one, you can write it here. P of x equals to minus x plus 1 by x, q of x equals to x minus x square. So this minus is whole, not there. Okay. So here further you can do minus x by x is minus 1, minus 1 by x. Okay. So now you can do the integration. So first one will be minus x. Okay. So constant we are not putting. Okay, it will be adjusted with the solution. Okay. So here if you want, you can write it as 1 by x e power minus x. Okay. So if you take this one and logarithm, this comes to 1 by x. So this is your integrating factor. If you want, you can multiply now. Okay. Or you can directly put it in the equation y equals to minus px dx form. So the solution here, y equals to e power minus px dx form. So if you put minus here, then you have q of x. So see this, look at here. Okay. So now if you substitute here, this is minus. So if you multiply minus here, so x plus n x, so it will be x e power x form. So the first term, it will be x e power x form. So now the second term, q of x. What is q of x here? X minus x square. So you put it here, x minus x square. And here e power b dx here is the integrating factor, 1 by x e power minus x. Okay. Or integral form I missed, qx dx plus the constant. So here x e power x, and if you cancel out here x gets cancelled, we have e power minus x e power minus x dx plus c. So if we do the integration, then we have x square. So look at it, we have x e power x. Then here we have e power minus x. And how much will be this one, the integral x e power x? E power minus x, 1 minus x. So what you can say? So we will have, here is e power minus x. If you take common, it will be adjusted here. So let's write this one is of this form, 1 minus x, e power minus x. And here we will have 1 minus x. So find it, how much will be this one? Solve it and tell me.
minus e power minus x whole into 2 plus x.
2 plus 6 minus only the inside part you are telling?
Yes, ma'am. The entire
Minus.
integration.
Minus? What is it?
Minus e power minus x whole into 2 plus x.
2 plus x. And this c will be there. C will be here.
Yes, ma'am.
Okay. So if you multiply, this will get cancelled and we have x minus sign. 2 plus x constant. So here minus 2x plus x square. So y will be this much. Somewhere e power x will be there. Okay, we are multiplying e power x. So here also x, e power x, x, e power x. Okay. So here this minus 2x term is coming extra.
Yes, ma'am. Minus 2x is not there.
2 will be there
Minus
or it will.
2x minus x square.
No, ma'am.
No,
The
what
answer
I'm
will be
saying
y
is,
equal to x square plus c e to the power x.
yes. So this 2 won't be there here in the integral. It will be
Yes,
only
ma'am.
x power area.
Yes, ma'am. One minus one will come into picture, and the other way plus one, and both they will get cancelled.
Oh, yes. So we will have here x square. This minus will be there or this minus won't be there. So y will be x square plus. So you check your answer. This is what we are getting.
Yes, ma'am.
So this is the answer. Now the next one you try. Let's say initial value. So dy by dx. So initial value means you will be having one value and at the end you have to substitute and find the value of the constant. Sine 2x.
Ma'am, y sec x equal to minus 2 cos x plus c
Y sec x equals
equal
to.
to minus 2 cos x plus c.
Okay. Others, are you getting this?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, one more you do.
Ma'am, C is equals to 3. You already
Yes,
gave.
yes. I gave you the initial value. You have to put it here. Okay. So C
C.
is coming 3.
Yes, ma'am.
Just check. Okay, all of you. C is coming 3. Then you will have this solution here. That means it's dependent on constant. You have initial value, then you will be getting one exact value of C.
Ma'am, it is coming to be y is equals to 3 minus 2 cos square x.
3 cos x minus 2 cos square x.
Okay. Solve it and I will see how many values you are getting. Others also do it. I will tell you. So then now one more question you can write. Cot 3x. Okay. So first of all, you have to write it in the form. So you are able to write it?
Yes, ma'am. Ma'am, it's coming y cos 3x equal to minus cos 6x by 12 plus x minus sin 6x by 6 plus c.
Y cos 3x equals to?
Ma'am, I can simplify it a bit.
Okay. What is the integrating factor?
Ma'am, cos 3x.
Cos 3x. Okay. So you write it in that form, then you will have and the integrating factor, it's coming as
Cos
sine 3x,
3x.
cos
Cos 3x.
3x.
Yes, ma'am.
So I'm writing directly. Okay. So it is like e power p dx. So it is here minus 3 tan 3x dx. So here this is p of x and this is should be q of x. So then you find out the solution. See, it's up to you. In some solutions, you may find it of this form, p dx, and this is equals to q. Okay, in some book you find it of this form. Okay, so I've written in the UI form. So what you are getting finally, y cos 3x. You
Y
Yes,
are
ma'am.
saying
Y cos 3x equal to minus cos 6x by 12
minus cos 6x by 12.
Yes, ma'am.
Yes.
Plus
Then
plus
this
x.
much only.
No, ma'am. Plus
Minus
x.
sine 6 by 12. Min
Then
minus sine 6 by 12.
sine 6x by
By
12
12 plus x by 2.
and one constant.
Plus 3.
So you can take minus 1 by 12 out and you can make it 6x minus cos 6x sine 6x. So this is your solution. So again you practice. Here we have 4.5. Exercise 4.5 is for this linear first order differential equation. Okay. So you have the solution and okay, so direct one. Okay. So here from the Jan angle we have the exercise. Simple questions. Okay. So you do the exercise is 4.5. Next, we have some special first order differential equations. So, so tomorrow, can I take one class that you were taking Wednesday? I want to take one more class. Okay, I will talk to you, Sian. Okay. So it's time. Okay, I'm ending the class.
ମା ଟିକେ ପାଣି ଦେ